Hello, everybody. So for this lab, we are going to go over the Hydrate Lab. So we're going to dehydrate a crystal that has water and just get rid of the water and just try to calculate our yield and see where this goes. All right. So at this point, you should have read this discussion here, the purpose, completed the pre-lab, and read the procedure and drawn the procedure as shown here in step 3 for the pre-lab. All right. So first things first, we do have to be safe. So let's go ahead and make sure we have our gloves on. So I don't want to come into contact with the hydrate. It's not completely dangerous, but it's still dangerous. And make sure we have our goggles on. We're going to put those on. Okay. So first things first is that we have our crucible. This is what it looks like. We have to make sure it's clean, and then we start weighing out the crucible. So this is the point where we start collecting our data, and we can follow the steps, or this portion here will remind us what to do. So we get the mass of the crucible. So I turn on my scale. I'm going to zoom in a little bit. I tare it, make sure it's in grams, place it, and it's 16.96 grams. So I'm going to write that out, 16.96, and everybody's crucible will be a little bit different. Now I'm going to weigh out my hydrate. Notice it's a blue powder. So in this case, we do not have to crush the crystal with the pestle or the motor. So I'll leave that aside. I'm just going to scoop up an unspecific amount, and that should be good right there. So let's go. My weight just went up to 18.92. So let's go ahead and record that. Now, massive dish plus anhydrous salt. This is where the fun begins, and we actually start burning our sample. So let's go ahead and see what that looks like. So here's our Bunsen burner with the ring stand. We'll go ahead and flip this. Oops, doesn't work out that way. Okay. So in this situation, what we want to do here is go ahead and place our crucible. Notice there's no flame here, so it's not turned on. So I'm going to go ahead and turn on my gas. You hear a little hissing sound. We don't need too much gas. And we're going to go ahead and ignite a Bunsen burner. There it is. And at this point, since we are going to be working closely in front of the fire, make sure you tie your hair back and put on your heat-resistant gloves. Alright, so this is just to make sure we don't get burnt. If you wish to, you should take off your latex gloves. You can take those off. I have mine on, but take them off if you need to. And actually, it is best. Just go ahead and take them off now. Reason being is that these heat-resistant gloves won't melt, but the gloves will melt, and that can burn our skin. All right, so let's get started. So if you noticed earlier, you saw that our powder was blue. Now you're going to grab. Ooh, this is kind of slippery. So I'm going to take off one of the heat-resistant gloves, get a better grip of the crucible. And notice with my other hand that has a heat-resistant glove and the stirring rod, I just casually and gently stir my powder, and I crush any clumps that are in here. And you're going to keep doing this for maybe 5 minutes. Luckily, we're wearing masks right now, so you don't have to breathe any of these fumes. So keep doing this until your hydrate turns white, and that'll symbolize that all of the water has been taken away. So please do this until your powder turns white and not some gray clump. So I'm going to show you really closely what I'm doing. So here's a clump, and I'm just stirring like this, just gently. So once again, keep doing this, and once you're done, you're going to let this cool down for a good 10 minutes, and then you're going to place this back on your scale and weigh this. All right. So while you're waiting, you can work on the post log. So I'm going to stop this, but you should continue until everything turns completely white. Mine still needs some time, but that's all the time I have. And there it is. So keep on stirring. So now that all of the water has evaporated from my hydrate, it has turned into an anhydrous salt. So it's just copper sulfate, and it has a with the crucible it has a mass of 17.5. So now to calculate the mass of my hydrate and the anhydrous salt, I'm going to do these calculations down here, and I'll be calculating all of these answers with my values, these three here, and you'll be doing this with your own. So anyways, the mass of hydrate, I'm just subtracting mass of dish plus hydrate, so that's letter B minus letter A up here. So this will be equal to 18.92 minus 16.96. That's going to be equal to 0.6. 9. So 1.96. Just to verify, minus 19.96. Okay, so now the mass of anhydrous salt, this is now letter C minus letter A. So we're just trying to figure out how much our powder weighs without the crucible, because the crucible is not reacting, our powder is. 17.5 minus 16.96. Take it to 17.9.5 minus 16.96. 0.54. Okay, so our crystal with the water weighed this much, and our crystal without the water weighed that much. So let's go ahead and calculate the yield. And the yield is kind of like measuring how accurate my results were, and then I'd be able to critique my technique or the lab itself. Mass of water lost, this is number 2. Mass of the hydrate minus the anhydrous salt. So my bad, number 1 minus number 2. So this is equal to 1 point minus 0.54. Now we get 1.42. And this is how much water we lost, or better yet, I lost. Okay, so now here the theoretical yield, this is where we get our answer. It kind of tells us how much of an error we did. So earlier, let me get rid of this right here. What we're doing here, we calculated the percent composition of water. You did this in the previous assignment. And overall, you calculated the mass of water in the hydrate, which is 18 times 5, which is 90. Or 5 times 18, yep, 90. And we divide by the total mass of copper sulfate pentahydrate, which is 249.68. So we added the copper sulfate plus the water. So it's 90 divided by 249.68. In this case, we get, don't need that. There you go. 90 divided by 249.68, which is equal to 36. Multiply times 100 to get the percentage, and we get 36%. So 36% of our substance should have been water. So let's see what this was now. All right. So now in this case, to get the yield, we're going to multiply the percentage of water times the mass of the original hydrate. So we're going to do 0.36 times whatever value you had for this portion here, because this is the mass of our hydrate. So I'm going to do 0.36 times 1.96. So 0.36 times 1.96. So I should have gotten or I should have released 0.76 grams of water. Once again, this is how much water should have been, how many grams of water should have been in my hydrate. 0.70. Everybody's going to get a different value because we're getting different amounts of hydrate. All right, so now for our percent error. Notice my theoretical water loss should have been this value here. In theory, that's how much water I should have lost, but in practice, I lost 1.42. So let's calculate the error. So in this case, we're going to use this formula. So this is the absolute value of the difference between the theoretical water loss. So that's this value here. In theory, I should have lost 0.7. 0.7 minus what I lost, 1.42. And this is all divided by theoretical amount of 0.7. So this is equal to, and by the way, since this is absolute value, then any negative value turns into a positive value. So I got 0.72 divided by 0.7. And then I also have to multiply times 100%, or 100 to get the percentage. So if we do this, 7 times 100. Oops, that's where it's at. So this is saying I got an error of 100%. This is saying that I completely screwed up if I was in industry. With that error, I probably would have gotten fired, or I'd have to redo the lab. So anyways, at this point, please go ahead and complete the conclusion and the rest of this post-lab. Anyways, thank you for trying this out, and talk to your teacher about any of these calculations or your results.